Okay, so if you look in your notes, you have 6 angle addition laws written out. So there's, I guess technically speaking, it's 3, sine, cosine, and tangent. But for each of them, we demonstrate it both with plus and minus. So the first 3 that you see here are sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha plus beta. And when you are adding 2 angles within sine, so sine of alpha plus beta here, okay, then each of those angles gets split up as follows. First, you would have the sine of your first angle and cosine of your second angle, and then cosine of your first angle and sine of your second angle. And then notice that the sine stays the same with sine. If we are adding the 2 angles, we still add them as we split it up, right? Same will then be true for subtraction, right? If we are doing sine of alpha minus beta, those 2 angles get split up as, here, sine of the first angle, cosine of the second angle, cosine of the first angle, sine of the second angle. So the same as they got split up with plus or with addition. It's just now we're subtracting, and notice we still are subtracting when we split up our sine. Okay. Cosine is similar, but some slight differences here. And when we are adding or subtracting within cosine, then the 2 angles alpha and beta both get cosine initially, and then sine as our second one. The difference here with between sine and cosine is that when we are adding within cosine, we subtract when we split them up, versus sine, where the sign stays the same. Adding stays adding. Okay, same is true then for subtraction. Okay, when we are subtracting 2 angles within cosine, you have cosine of your first angle and cosine of your second angle, sine of your first angle, sine of your second angle. And then if you are subtracting within cosine, you end up adding as you separate it or expand it. Okay? And then with tangent, tangent's probably the most complicated looking of the lot. When you are adding 2 angles within tangent, okay, up top you would have those 2 angles with their respective tangents being added. So tangent of the first angle, tangent of the second angle. And then since we were adding within your original tangent, okay, you are still adding on top there. On bottom, then you have 1 minus, so different sign down on the bottom. Let me go ahead and highlight that. Different sign down on the bottom. And it would be 1 minus the 2 angles, alpha and beta, their tangents being multiplied together. Okay, in a similar pattern with subtraction, obviously, we have our tangent of alpha minus beta. And then on top here, your tangent alpha, tangent beta, so the first angle, second angle, being subtracted for both of them, since we were subtracting an original, subtracting here. Down below then is the opposite sign, so addition. And down below you would have your 1 and then plus tangent alpha, tangent beta. And then for each of these rules, there's little things that could happen for manipulation, not a ton, but a little bit here and there. So for example, a negative could get factored out or something like that. One that you'll see pretty quickly as you get into your homework is for these tangent ratios, if they were flipped upside down, well, that would mean that that was a -1 exponent, and a tangent to the -1 is actually cotangent. And so there's a little hint for one of your homework problems. Okay. And so these first 3 problems, we are looking at combining given cosines or sines or tangents. And so we're going to do one together. And then my recommendation is that you pause the video, try the next one on your own, restart it when you're ready to check your answer. Same thing for number 3. Okay, so doing this one together, the first thing you need to do is to look at what kind of trig are we working with here? Is this cosine, sine, or tangent? And as we look at these two, we see that we have a cosine of 110 and a cosine of 25 paired up together. Okay, so that one looks the most like cosine. With your sine here, we are minus, and so that one's going to look most like cosine of alpha plus beta. So this guy right here is what I'm looking at. That's the one that it pairs closely to. And in this case, it pairs almost exactly. So we know that this becomes cosine of alpha plus beta, 110 plus 25 degrees. It is tempting to want to say, well, where did that sine go back here, right? But notice that sine is part of my cosine expansion. So it's not that we're ignoring it. It's not that it goes away. It's a necessary part of being able to combine back into this form. We need both the duo cosine and the duo sine to be able to combine back into cosine alpha plus beta. Okay, so we've combined back into cosine alpha plus beta, which means this is cosine of 110 plus 25 is 135 degrees. And then that is one we actually do know how to evaluate. 135 degrees is sitting in the second quadrant, and it's the 45-degree angle sitting in the second quadrant. Right here, right? This would be 90 to that angle, and then 45 more sends me to 135 degrees. So this has a reference angle of 45 degrees in the second quadrant. Well, cosine in the second quadrant is negative. And then 45 degrees, our reference angle here, is a cosine of root 2 over 2. Okay? So go ahead and try number 2. Pause the video, restart it when you're ready to check your answer or when you get stuck and need a helpful hint. Okay, with number 2, again, identifying what trig does this most look like. We see we have a sine cosine plus cosine sine. And so when I see sine and cosine mixed, that looks the most like the sine alpha plus beta. Okay, right here. And then noticing, which is the other reason I started the one I did, that I have a plus in the middle. Well, that's like that sine alpha plus beta. And so we are going to be combining our sine alpha cosine beta and our cosine alpha sine beta and going back, combining it to look like sine alpha plus beta. Okay. So then my sine of alpha, I don't need that parentheses, sorry. My sine of alpha, which is the pi over 12, plus beta, which is pi over 4. Okay, which I can combine by finding a common denominator. This would be pi over 12 plus 3 pi over 12 for the pi over 4, which is sine of 4 pi over 12, or sine of, if I reduced that, pi over 3, which is an angle I know. Pi over 3 is in the first quadrant. It's the equivalent to the 60-degree angle. And so sine would be root 3 over 2. Okay, go ahead and pause the video if you haven't already. Give number 3 a shot and restart it when you are ready. Okay, so again, identifying what does this one look most like. This looks most like tangent. I notice that I have a plus sign on top, so that one looks most like tangent of alpha plus beta. And so I'm going to be combining each of these things. So my tangent alpha, tangent beta, sending me back to tangent alpha plus beta. So tangent of my alpha plus beta is 15 degrees plus 30 degrees, which is tangent of 45 degrees, which we do know. In the first quadrant, tangent of 45 degrees is 1. Okay, so then that's combining. Okay, with number 4, we are looking at showing that the sine of A minus B does not equal the sine of A minus the sine of B. And so then showing that, let's go ahead and take a moment and figure out, well, what is the sine of A minus B? Well, if A is pi over 3 and B is pi over 6, I can go ahead and plug those in. A is pi over 3 minus pi over 6 for my B, which is sine of pi over 3 minus 2 pi over, I'm sorry, I wrote that backwards. I need to turn it into 6. 2 pi over 6 minus pi over 6. There we go. Pi over 3 is equivalent to 2 pi over 6, which is the sine of pi over 6. And we know what pi over 6 is. Pi over 6 is in the first quadrant, equivalent to the 30-degree angle. And the sine of pi over 6 is 1/2. Okay? And so then on the right side, well, what is sine of A minus sine of B? That'd be sine of pi over 3 minus sine of pi over 6. Both of those we know, they're both in the first quadrant. Pi over 3 equivalent to 60-degree angle. Sine is root 3 over 2. Sine of pi over 6, 30-degree angle, is equivalent to 1/2. And root 3 over 2 minus 1/2 is root 3 minus 1 over 2. And 1/2 does not equal root 3 minus 1 over 2. So the purpose of number 3 here is just to number 4 here is just to demonstrate why you do have to use the angle addition laws up here, the ones that we are starring. You have to use these 6 if you are looking to expand two angles within sine, cosine, or tangent. Okay? We actually cut number 5 and number 6. So you don't have to worry about those. Although number 6 might be a good one to try potentially if you're wanting some extra solving practice. You'll be doing actually some solving as we continue through the unit. So number 6 might not be a bad one to try if you were wanting to practice. Although I would only do part A if you're going to do that. Just because that's the restricted domain we work most with. Okay, and if you do work through number 6 and want me to check your answer, just send it to me, like through a picture, email, whatever. I'm more than happy to check that you did your solving correctly. Okay. Okay, number 7 though, we did do number 7 together because that one was new. Number 6 solving wasn't really new. Although I did modify the directions a little bit on number 7. I didn't want to do sine, cosine, and tangent all for one angle. I felt like that would get old kind of fast. And so I'll modify it similarly for this video. And then if you look at the homework directions, you'll notice I actually modified the homework directions so that for 3, 4, and 5, you were only doing one of the trigs for each of those. So sine for one of them, cosine for the next, and tangent for the other. Excuse me, sorry. I yawned. Okay, so starting us off here, theta of 165 degrees. Let's go ahead and just do sine of that one. And we'll do that together, and then I'll give you different angles for cosine and tangent so you can practice those. It's not ready. There we go. Okay, sine of 165 degrees. Okay, so the goal of number 7 here is that using angles that we know, so 30, 45, and 60, or some of their multiples. You don't have to use 30, 45, 60. You could use, for example, 120, because that is also an angle that we know how to find the trig of. It has a reference angle of 60. We are going to find two that will have a sum or difference equal to our theta, because then we can use all these expansion rules that we've been looking at to calculate the sine of 165 degrees is in an exact ratio. Okay, so your goal here is to take a moment and try to think about what are two angles that can add or subtract to give me 165 degrees. Okay, so go ahead and pause the video if you think you're going to need a little bit of extra time, but I'll go ahead and pause and give you a chance to think. Okay, and so then in class, and again, pause the video if you haven't come up with two, but in class, the two that I heard most frequently were 120 and 45 degrees, which add together to equal 165. I heard, let's see, 135 degrees and 30 degrees, both of which we know those add together to equal 165 degrees. And then I heard, let's see, there was one that was a subtraction. Let's see if I can remember what it was. Most people went with the additions, which is why those came to mind more quickly. I don't remember what the subtraction was. I apologize, but there was a subtraction that someone had found. But like I said, most people liked the addition ones, and so went with something like 120 degrees plus 45. Right? So we are using the sine alpha plus beta up at the top there, sine of alpha plus beta for this one, okay, which expands to sine of alpha cosine of beta plus cosine of alpha sine of beta. Okay, so coming down here, we have our expansion, sine of alpha cosine of beta plus cosine of alpha sine of beta for my alpha plus beta here. Okay. Now that you've expanded it, you've turned sine of 165 degrees, which we don't know how to evaluate by hand, into four angles that we can evaluate by hand. 120 degrees is in the second quadrant, the 60-degree angle in the second quadrant. And so we're looking at a positive sine. And so this would be root 3 over 2. 45-degree angle is in the first quadrant, so positive sine and cosine, root 2 over 2. Going back to our second quadrant for cosine of 120 degrees, so this would be a negative cosine, 1/2. And sine of 45 degrees is root 2 over 2. And so then combining these, we have root 3 times root 2 is root 6 over 2 times 2, which is 4. Negative 1 times root 2 is negative root 2. 2 times 2 is 4. And so this combines to root 6 minus root 2 over 4. Okay? Okay, so giving you one to try here on your own. We're going to go ahead and do cosine of 105 degrees. Go ahead and pause the video and restart it when you either have an answer or are ready to check your answer. I'm sorry, got stuck and need help getting to your answer. Okay, so thinking through what two angles did you come up with? And obviously, if you came up with two different angles than mine, you are going to have slightly different work, but your expansion should still look the same as mine, and your final answer should still be the same. If they aren't, send me a picture of your worked out work. It's possible it's not wrong. They're just, well, like not completely wrong. There might just be a little error in the work. And so I can take a look at help you find your error and help you fix your mistake. So just because you pick two different angles than mine doesn't necessarily mean you're wrong, just might be different, as long as they do add or subtract to give you 105 degrees. For me, I did 135 degrees minus 30 degrees because those are two angles I know I can evaluate. In class, the other one that I saw people do besides this one was 60 degrees plus 45 degrees. Again, it would have similar looking work, just slightly different. Your answer, those should still be the same. Okay. And so for mine, if I'm doing cosine of 135 minus 30, I'm using the cosine subtraction, the middle on the right up here. Okay, so cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And so coming down here, that means my alpha is going to be the 135, beta is going to be 30. And so we have cosine of alpha, so cosine of 135 degrees, cosine of beta, so cosine of 30 degrees. And then plus, because with cosine, your sign changes. Alpha minus beta has a plus in the middle. So plus here, sine of alpha, so sine of 135 degrees. Sine of beta, so sine of 30 degrees. Okay. And so then simplifying this, cosine of 135 degrees, we're looking at the 45-degree angle in the second quadrant. So cosine is negative in the second quadrant. So this would be negative root 2 over 2. Cosine of 30, first quadrant, so everything's positive. We're looking at root 3 over 2. Sine of 135 degrees, back to the 45-degree angle in the second quadrant. Sine is positive, so we're root 2 over 2. And back to the first quadrant, sine of 30 is 1/2. And so this simplifies to negative root 6 over 4 plus root 2 over 4, which simplifies to negative root 6 plus root 2 over 4. And it's possible, depending on what you chose for your initial starting values, you might have gotten root 2 minus root 6 over 4. That is also the right answer. Root 2 minus root 6 over 4. Okay, so then one more to walk through the tangent. Again, pause the video, try this one on your own. Restart it when you either have an answer or are stuck and need a tip. We have tangent of 15 degrees. Okay, and so then when I did this one, I used 45 degrees minus 30 degrees when we did it in class. I know I had some people who did 60 degrees minus 45 degrees. Both work. Again, slightly different work, but similar. Same answer though. Okay, so for subtracting tangent, we are looking here at tangent of alpha minus beta equals tangent alpha minus tangent beta over 1 plus tangent alpha times tangent beta. So coming down here, got my alpha and beta. So we have tangent alpha, so tangent of 45 degrees, minus tangent beta, tangent of 30 degrees, over 1 plus tangent alpha, so tangent 45 degrees, times tangent beta, tangent of 30 degrees. Okay, 45-degree angle and 30-degree angle are both in the first quadrant, so we're good with positive ratios. It's just making sure we know the tangents. Tangent of 45 degrees is 1. Tangent of 30 degrees is 1 over root 3. Bottom we have 1 plus 1 times 1 over root 3. And then simplifying this, we would have 1 minus 1 over root 3 over 1 plus 1 over root 3. And then to clear that fraction, we would be multiplying everything by root 3. Clear those extra denominators. On the top there, 1 times root 3 is root 3. The root 3's cancel in the second term, giving me minus 1. Over 1 times root 3 is root 3. Root 3's cancel, giving me plus 1. And you've got your answer. Okay, so again, if you tried working through these last three and used different angles for your addition and either addition or subtraction, didn't get the same answer as me, take a picture of it, send it to me. I'll check your work, help you figure out where you got off a little bit. And if you went through and solved 6a to get a little bit of extra practicing solving with our restricted domains there of 0 to 2 pi, take a picture of that as well. Send it to me. I'm more than happy to check your work if you would like.